it's Gina again. I'm just going to show you kind of the wiring that I've used for my final project for Comp 444. As you can see, I've used my Spark Inventors kit box and kind of repurposed it as my main chassis for my robot. As you go around, we have these wheels I described in the in my report as what I 3D printed. Needed a little bit of extra grip on them, so I added a roll of duct tape. This right here is my ultrasonic sensor on the front. This is my flame sensor here. Got an LCD, this great big monstrous fan. Yeah, let's open it up and see what we got inside. So inside my robot, we have 2 boards. This right here is my main board, Spark Inventor Fun Kit red board with a motor shield that's been attached to it to operate my motors. Then here we have Maestro. So this is the name of this board right here. It operates mostly this speaker right here that's been taped up, and it also operates the LCD, and that's what these wires going up to the top is. So working from the diagram, or working from my batteries out, so I have 6 AA batteries to provide all the voltage, which is going up to this power switch for easy on, easy off. Down wired directly to 2 places. So the first place it's wired to is into the my compact motor shield, or my motor driver, my CMD. In order to decrease the voltage to 4.5 in order for that voltage, and that's what's in that blue spot right there. The other spot that it goes is takes these 9 volts and goes directly all the way over here to this side of the breadboard, which I have taped off to ensure I didn't plug anything in there I didn't want. And the reason it does this is it goes unrestricted from my batteries to this relay switch, which then goes up and operates my fan. That way I get the most power going to my fan, because if I run it through one of my boards, then it's going to decrease the voltage, and that just wasn't enough power. Going back to my main board again, we have all these broken out pins. It's the first time I soldered was during this project, putting this board together, and I'm pretty pleased overall how it went out. Primary is these right here, which is pin number A0. It goes directly to my sensor, my ultrasonic sensor up the front. Then we have, where should we go to next? A4. So analog 4 is kind of a tricky one. Analog 4 along with analog 5, those are my my communication lines. So they go from this board, which I call engine in my code, all the way up here to Maestro, going to the exact same ports, which will be analog 4 and 5. So this is the predetermined, I guess, conversation lines, which I found on the old Google machine. Also going from one board to the other is the voltage and ground, just coming off of 4 and 5, or sorry, just coming off of 5 voltage and ground to the voltage and ground from here. So that way one board powers the other board. That way I can't run one without the other. I don't know on this specific project where I'd want to do that. My speaker right here, if I continue on Mr. Maestro, comes down to, what pins are we going to here? There they are. So it comes down here to pin number 9, this brown wire right here, and then this white one is just going to ground. Didn't use a breadboard a lot for this, again, just because I didn't have to, with the exception of some of my all of my ports, I guess, I used for the LCD screen. So all of those kind of are fed up in this direction right here, going down in this downwards direction, and then fed through the breadboard. This was done because, well, I didn't have enough male to female connections to make them all work the way I wanted to. It just really helped me keep myself organized on kind of which was going where. Other functionality I have here, I have a little dial switch here to change the brightness of my LCD screen. If I need to, I can open it up and change that. And then I guess the only other thing is my RGB light. So my LCD light right here, I use this little embedded circuit that already has resistors on it. And because of that, I was able to, again, because I didn't have enough male to female connectors, or I guess it would be male to or female to female connectors, to be able to go from here directly to my board. I went through the breadboard again. So I went from this RGB, which I actually used red, green, and blue wires, and then ground being brown. And then coming down, boop, down to my board, and then over, using some different colors over here, 2 pins number 13, 12, and 10. Yeah, 13, 12, and 10. So there we go. I guess the other thing is my motor controllers, which are these blue connectors right here. They have positive and negative charges. And why I really like this compact motor driver is because it will reverse polarity for me in order to make my motors either go frontwards or backwards, allowing my robot to turn really, really well. So that is the wiring for my firefighting robot. Thank you very much.